Guys, this is a very important example, and we will see how it teaches us something fundamental about transitive relations. So in this question we have to check whether this is reflexive, symmetric and transitive. First, let's check if this is reflexive. Guys, in reflexive we check for x comma x. Now for x comma y, the relation is given y equals to x plus 5. So for x comma x, the relation will be x equals to x plus 5. Tell me guys, is x equals to x plus 5? No, can never be. So how will this be in the relation? This will not be in the relation. The condition does not satisfy. So this is not reflexive. How do we write this, guys? Excuse me for a second. How do we write this, guys? So the way we write it is, so as I have told you before, if we have to prove that a condition is not reflexive, then we have to prove it with one example. So I am giving one example as 1 comma 1 does not belong to the relation if it is not reflexive. Okay, guys, tell me, could we have written 5 comma 5 instead of 1 comma 1? No, because see, for the value of x is less than 4, we cannot use a value of greater than 4. Okay, so next let's check if this is symmetric. So how do we prove a relation is symmetric or not? X comma y has to be in the relation, y comma x has to be in the relation, only then. So when will x comma y be in the relation? What is the condition? Y equals to x plus 5. In the same way, when will y comma x be in the relation? When the condition will follow that x equals to y plus 5. Guys, simple to understand. For x comma y equals to x plus 5. For y comma x equals to y plus 5. Okay, let's take a value of x equals to 1, then y will be x plus 5, y will be 6. See, for this condition, for this set of values, the condition follow, right? Am I right? But if we take the same values, so y equals to 6 and x equals to 1, see, now this condition doesn't follow. Why doesn't it follow? See, if you put the value of y here, 6 plus 5 is 11, but y becomes 11, not 1. How will this condition satisfy? It doesn't. So x plus y belongs to the relation, but so x comma y belongs to the relation, but y comma x does not belong to the relation. Therefore, it is not symmetric. How do we write this? When something is not symmetric, we prove it with one example. As 1 comma 6 belong to the relation, but 6 comma 1 does not belong to the relation, therefore it is not symmetric. Now, the most important part. We have to check if this is transitive or not. Guys, before starting transitive, I will ask you one question. When is a relation not transitive? To be not transitive, two conditions has to follow. If x comma y belongs to the relation and y comma z belongs to the relation, both of these belongs to the relation, even after that, even then, if x comma z does not belong to the relation, only then we say that look, these two belongs to the relation, then even after that this does not belong to the relation, therefore this is not transitive. Okay, so if y comma z itself is not present, we cannot prove this is not transitive, therefore it is transitive. So to simplify, in any relation where y comma z is not present, x comma z will also not be present, therefore we can't prove that this is not transitive, therefore it is transitive. Now let's check. What did I say? For this to be transitive, x comma y has to belong to the relation, y comma z has to belong to the relation, x comma z has to belong to the relation. When will x comma y belong to the relation? When this condition will follow, y equals to x plus 5. Take a value of x, let's say x equals to 1, y equals to 6. Look guys, the condition follows. When will y comma z belong to the relation? When, see, for yz, it will be z equals to x plus, z equals to y plus 5. See, x, y, y, z, z. Okay, same thing just with different letters. Now we can say that y was already 6, so y equals to 6, z equals to 6 plus 5, which is 11. For this, the condition, it will look like the condition follows. However, look guys, it is given in the question that x has to be less than 4. Or for yz, y has to be less than 4. Is y less than 4? No. So guys, y comma z can never be in the relation. Y comma z is not present in the relation. If y comma z is not present in the relation, can we say this is not transitive? We cannot prove that this is not transitive. So we say that this condition is transitive. Look how I wrote this. As x comma y belongs to the relation, but y comma z does not belong to the relation. Therefore, R is transitive. Simple thing to remember, guys. X comma y is present, but y comma z is not present. Then we can say it is transitive. That is a simple condition that you can remember while attempting questions in exams. Okay? Remember this, guys. If this type of question come in exam, don't get fooled. Bye.